I'm going to use the same terms over and over. All of our trig functions are what are called periodic functions because they repeat after a certain length of time. How long it takes them to repeat is called the period of your function, just how long until it repeats. So today we're talking about sine and cosine. They're periodic because they repeat. The period, how long do you think it takes until they start repeating? Think about your unit circle. How long does it take to get all the way around the circle in radians? 2 pi. And after you go all the way around, what happens to your values? They repeat, right? So sine and cosine have a period of 2 pi. That's the distance to get all the way around the circle. Once you're all the way around the circle, it starts repeating itself. So what I want to do is go to this handout first, and we are going to talk about the graph of sine. Anytime you're graphing things, if you don't know what a graph looks like, you make a t-chart, right? That's essentially what this is. My angles, those are like the x's that you put in, they're going to go in for the theta, and we're going to see what y is, or our sine. Okay, so x is the angle, y is the sine. So 0, think about your hand trick. What is the sine of 0? 0. Okay, or if you think about your unit circle, sine is the y, so it's 0. At pi over 2 or 90, what's sine? 1. Okay, what's the sine of pi? 0. What's the sine of 3 pi over 2? 2 pi, that's the same thing as 0, right? So I'm back to 0. This is where it starts repeating. Okay, so on my y value, my high point is 1, my low point is -1. The x-axis is going to be my angles. So we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so if I'm plotting these points, sine of 0 is 0. Sine of pi over 2 is 1. Pi is 0. 3 pi over 2 is -1. 2 pi is 0. Now, is this a real clear picture? Maybe not. But what I put on this handout is our basics. Anytime we graph it, we are going to need these points. Now, if for the first time, if we're not really sure, we could always do more points, right? So it's up to you. You don't necessarily have to put these on yours, but if I were trying to get a few more points, think about like pi over 6, that's 30 degrees, right? So a third of the way. What's the sine of 30 degrees? 1/2. Okay? 2/3 of the way. That would be 60 degrees, or pi over 3. What's the sine of pi over 3? Radical 3 over 2. If you look at that in decimal form, you can see if you divide those, it's 0.86. So is this a straight line up there? No, it's curved. And if you kept going, here we're back to radical 3 over 2. Here we're back to 1/2. This is a curve. Ooh, maybe. So sine and cosine are a lot of times called waves. It's just a curve going back and forth. So the extra points are really just there for me to show you that it's curved. After this, now you know. When you draw it, don't draw me a zigzag. It is a curve. Now, does it really stop at 0 and end at 2 pi? No, it's going to keep going. And it's just going to keep repeating itself. If you kept drawing, it's just going to go up and down, both directions. Okay, it's just going back and forth. And we could talk about domain and range. Domain is my x. What can I put in? Because we just said it's going to keep going, right? So what would my domain turn out to be? But what's my range? Didn't we already say that about sine back in chapter 1? We had questions and I would say, is this possible or impossible? Sine equals 2. And you would tell me it was impossible. We knew that sine could only be between -1 and 1. All right. So anytime I'm graphing a sine function, we are going to use these points. 0, pi over 2, pi, 3 pi over 2, 2 pi. Those represents the quadrantal angles, the points on the x and y axis. So that will give us our foundation for what the graph looks like. Are there any questions on how we got our graph of sine? And this is just showing you the picture where it keeps going both ways, okay? Let's talk about cosine then. So you can think about your unit circle, you can think about your hand trick. What's the cosine of 0? 1. Cosine of pi over 2. Cosine of pi. 3 pi over 2. 2 pi, you're back to where you started, and it's back to 1. So if we plot these, cosine 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. 3 pi over 2 is 0. 2 pi is 1. We could do like I did on the last one and put in some more points, but do you think this is a zigzag or a curve? A curve. For the same reason. If we plotted like at pi over 6, you're at radical 3 over 2. At pi over 3, you're at 1/2. So the graph should look like this. And again, does it just end when I get here? No, it's just going to keep going both directions, following the same pattern. What's my domain then? And the range, what y values do we get? So that's all we are doing on your handout today. Now we're just going to go to our notebooks for everything else. I have a picture here just illustrating this is what 2 periods, a period is just until it repeats, so this is 2 complete graphs of cosine. Okay, one property that we'll sometimes talk about with these functions is even and odd. We used this terminology back in college algebra. Remember, even means symmetric to the y-axis. And odd means symmetric to the origin. So if I look at sine, if I fold this graph over the y-axis, does it overlap itself? No, if I fold it over the y, it's going to be going up here. If I fold it over the origin, that means flip it over the y, then flip it over the x. Does it overlap? Yes. So sine is an odd function. It's symmetric to the origin. which means odd. The important piece there, the definition of odd says if you have sine of a negative angle, you get the opposite of sine. So because sine is odd, if you have a negative on your angle, you can essentially factor that out using the properties of odd functions. If I look at cosine, all right, so if I flip this over the y-axis, does it overlap? What if you look like right here? Yeah, if I flip this over the y, it's the same on both sides. So cosine is symmetric to the y-axis, which means it is even. What that means is when you have the cosine of a negative angle, you get the exact same value as cosine of the positive angle. So cosine of a negative x is equal to cosine of x. So sine is odd, so a negative on the angle will go out in front. Cosine is even, so if there's a negative on the angle, we can drop it. All right. What we're going to look at now is what are some changes to these graphs. You know from college algebra, we have x squared, that's our parent function, but I could do 2x squared, or x plus 3 squared, or x squared plus 4, and all those transformations move our graph, right? Those transformation rules are the same with our trig functions, but they sometimes use slightly different terminology. So I want to take a look at a couple aspects of that today. We're not going to get into all of them yet, maybe 2 pieces of it today. So first, I want to graph y equals 2 sine of x and see how that is different than regular sine. I think usually it's easier for you to graph these in your notebooks because some people like making really big graphs, some people make really tiny graphs. It's totally up to you. If you want a ruler for the purpose of drawing straight lines for an x and y axis, I have some. You're welcome to one. The graphs themselves are curved, so we don't have to worry about that part. So my points that I'm putting on my axis, these are like the x and y axis points. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. You should always have 5 points on the x-axis. Each of these, and we have to start back or end where we started, okay? One thing I want you to be aware of, the distance between each of these is the same, right? This is like 0 to 90, 90 to 180, 180 to 270. They're all a distance of 90 degrees or pi over 2 radians. So please try to space them evenly. I'm not taking a ruler and measuring to make sure they're exact, but if you have 2 really close together and 2 really far apart, it will really warp your graph. So just try to take the time to make sure those are approximately evenly spaced. All right, let's talk about regular sine first. Okay, these are just the values of sine. What is the sine of 0? Okay, what's the sine of pi over 2? Sine of pi? 3 pi over 2? 2 pi? So it's basically start at 0, up, back to 0, down, back to 0. You're just bouncing back and forth. So this is what sine typically looks like. Okay, and I'm just putting it on here because I asked you to compare the graphs. So, all right. What would happen if I did 2 sine of x? That means 2 times the sine of x. So the sine of 0 is 0. Times 2, 0. Okay, sine of pi over 2 is 1. Times 2 2. Sine of pi is 0 times 0 is still 0. Sine of 3 pi over 2 was negative 1 times 2. Okay, and sine 2 pi is 0 times 2 is still 0. So what did that 2 do? It was a vertical stretch. Isn't that what our transformations did before? If you multiplied the y times 2, it got taller and skinnier. So same thing here. That's usually referred to, and I'll put this slide up in a second. With trig functions, we call that the amplitude. It has to do with like waves. Trig functions, sine, cosine are waves. So the height of a wave is called the amplitude of it. All right. What do you think would happen on this one? Let's see. Putting our x-axis points to the multiples of pi over 2, evenly spaced. All right, what's the cosine of 0? Cosine of pi over 2 is pi negative 1. Then we come back up, at 3 pi over 2 is 0. 2 pi, we're back where we started at 1. So if I said 1/2 cosine of x, so 1/2 times the cosine. Cosine of 0 is 1 times a half is just 1/2. Cosine of pi over 2 is 0. 0 times a half is still 0. Cosine of pi is negative 1 times a half is negative 1/2. 3 pi over 2 would still be 0, and 2 pi would give us 1/2. So we were right. That 1/2 was a compression. It caused our graph to get shorter. Any questions on those? So, what we just discovered was the amplitude. The amplitude of a periodic function is half the difference between the maximum and minimum values. Okay, if my maximum is at 2, my minimum is at -2, my amplitude is 2. So a number out in front changes our amplitude, the height of our graph. Let's see what a number on the inside does. So if I said graph y equals sine of 2x. If I start with my normal points, pi over 2, pi, 3 pi over 2, and 2 pi. All right. If I'm evaluating, if I put in 0, 2 times 0 is 0. What's the sign of 0?
0.
0. if I put in pi over 2, 2 times pi over 2 is pi. What's the sign of pi? 0. All right, if I put in pi, pi times 2 is 2 pi. What's the sign of 2 pi? If I put in 3 pi over 2, 2 times 3 pi over 2 is 3 pi. What's the sign of 3 pi? 0. It's the same as the sign of pi. If I put in a 2 pi, I get sign of 4 pi, which is 0. So does that mean this is just a straight line, horizontal line? Probably not. What would happen if I put in halfway in between 0 and 90 is 45, so pi over 4. If I did my multiples of pi over 4, I made this too small, didn't I? Excuse my tiny writing here. Okay, if I put in pi over 4, 2 times pi over 4 is pi over 2. What's the sign of pi over 2? Positive 1. Pi over 2 will be right here. Okay, if I put in 3 pi over 4, times 2 is 3 pi over 2. Sign of 3 pi over 2 is negative 4. Okay, if I put in 5 pi over 4, I get 5 pi over 2, which is the same as pi over 2. 7 pi over 4 times 2 is 7 pi over 2, which is the same as 3 pi over 2. So when I graph this, how many periods did I just graph? I have 2 complete cycles of sine, don't I? We have 0, we hit 0, we're back to where we started, and we repeat. So this 2 did what? It compressed it, horizontal compression. Isn't that the same thing as we had before? Okay. In terms of our trig functions, that changed the period, the length of time until it started to repeat itself. So our transformation rules are the same, but we are going to kind of summarize this using our trig vocab here. All right, what do you think would happen if I put a 1/2 x? It would stretch it out. So then instead of repeating after 2 pi, it wouldn't repeat until we got to 4 pi. It would make it get longer. All right. If you have sine or cosine with a number multiplied with x, that changes the period, the length of time until it repeats. And our period is found by taking 2 pi, the normal period, and dividing by that number. So, when we graph our trig functions, we are going to list out certain information every time. The things that I want you to list, we will find the amplitude, period, count by, I'll explain that in a minute, and then we will plot our points and schedule. So this is a summary of what we have so far. And then I'm going to show you on the next example how we put all of that together. So we don't want to get stuck like making a t-chart every time we graph these trig functions. So what we're going to use is the pattern that we've already seen. Like sine starts at 0 and goes up first. Cosine starts up and goes down. And we'll use that pattern to get our graphs every time. So if I ask you to graph this over 2 periods, every time we are going to list certain information. The amplitude, the period, and what I call the count by. Amplitude is the highest and lowest point. We find it just by the coefficient. What is my amplitude here? 2. So my high point will be at 2, my low point will be at -2. My period. The normal period for sine and cosine is 2 pi. You have to divide that by the number being multiplied with x. So 2 pi over 3, and that doesn't reduce. That means my graph, when I start at 0, when I get to 2 pi over 3, it will be ready to start repeating itself. That's how long until it repeats. So our count by. These are the nice points we need so that we hit our high point, 0, our low point. So those points on the x-axis. To find them, think of it as the period. Let's switch my color. So we'll always take what we get for our period, and we will divide it by 4 for the 4 quadrants. Because our standard points are based off the quadrants. So we'll take the length of the graph divided by 4. Right, keep it in terms of pi, keep it fraction form. That being said, if you struggle with fractions, there is no harm in using a calculator and just doing 2/3 divided by 4 and getting your answer and tacking the pi back on. Okay, so that's not a big deal if you need to do that. And we get pi over 6. Okay. This is all the information we need to draw our graph. So my amplitude is 2. That means my highest point will be at +2. My lowest point will be at -2. So I put those on my x and y axis, or on my y-axis. I'm counting by pi over 6, so I start at 0. My next point will be pi over 6. To get the next one, you just keep adding your count by. So we add pi over 6. What's pi over 6 plus pi over 6? 2 pi over 6, which reduces to pi over 3. Okay, 2 pi over 6 plus 1 pi over 6 would be 3 pi over 6, which reduces to 3 pi over 6 plus 1 pi over 6 is 4 pi over 6, which is 2 pi over 3. Does that look familiar? That was our period. So that is my 5th and final point, right? I told you you'd have 5 points on the x-axis. Now, if you struggle with those, just use your calculator. You take the point you're at, you add your count by, just don't put in the pi's, right? And just keep adding the 1 over 6 every time. Now, we are graphing sine. Where does sine start? At 0. If you forget, plug it in. If I do 2 times the sine of 0, I get 0. Okay, then think about the graph that we did on our paper. What does sine do next? It goes up. So at this point, I should be at my high point, which we already know is 2. Then it has to come back to 0. Then we should hit our low point, -2, and then back to 0. If you get confused, you can always plug these points into our equation. We're just trying to shorten the process a little bit. We already picked all the nice points to make this work out. So, here is my graph of sine. So that's 2 sine of 3x. Now, I told you to graph it over 2 periods. How many periods did I just graph? 1. What do you think we would need to do if I wanted 2 periods? Add more points. All right, I already have my starting point. For each period, you just need 5 total points, right? You're starting and 4 additional. I'm at my starting, so I need to get 4 additional points. How do I find those 4 additional points? Add pi over 6. So use the calculator if you need to. 2/3 plus 1/6. And we get 5 pi over 6. Plus 1 over 6 would just give us Plus 1 over 6 would be 7 pi over 6. Plus 1 over 6 would be 8 pi over 6 or 4 pi over 3. All right, and then what do I do? How do I get my points? Should follow the same pattern, right? I'm at 0, so now it should go up to my high point of 2, back to 0, down to my low point of -2, back to 0. Make sure that it's curved. That's not a zigzag when you draw it. What if I said 3 periods? Add 4 more points. Could I put my points going this way too? Yeah, you would just subtract your count by. So you can add it onto either end. All right. Any questions on that one? Okay. I am going to stop here for today. Tomorrow, perhaps I was being a little bit lazy here. You'll notice it just says Chapter 4 assignment. It's everything for this chapter. I just didn't save them as individual documents. So we are on the section 4.1 handout, which is like 1 through 18. So that will be due on Monday. Tomorrow we'll keep working with this. If I have some time at the end of tomorrow, I might do an intro to section 4.2, but the 4.1 handout is due Monday. And you do them on notebook paper and we'll turn that in. Are there any questions there? How many of you are gone tomorrow? Oh, just you guys. All right. Will you be able to watch my video? Okay.